Welcome to a screencast on composing two functions. Let's start by reviewing the definition of a composition of functions. Let f and g be functions such that function g takes inputs from set A and pairs them with outputs from set B. And let function f be a function that takes inputs from set B and pairs them with outputs from set C. Then we define the composition of f and g to be the new function h that takes inputs from set A and pairs them with outputs from set C. And we represent this by this new function h of t equals f of g of t. We also sometimes use the notation h equals f circle g, where f circle g is the single function defined by f circle g of t equals f of g of t. So let's take a look at composite functions and see how they might work. Let y equal q of t equal the square root of t plus 1, and let t equal f of x equal x squared plus 9. Is it possible to combine these processes to generate a new function so that y is a function of x? Right now, y is a function of t, and t is a function of x. Well, since y depends on t, and t depends on x, it follows that we can think of y depending directly on x. We can use substitution and the notation of functions to determine this relationship. So first, it's important to realize what the rule for q tells us. In words, q is saying to generate outputs that correspond to a particular input, take the square root of that input and add 1. So in symbols, it would look something like this. Now, observing that y equals q of t and t is equal to f of x, we can substitute the expression f of x for t in the function q. So doing so would look like this. We would have q of t, and we know that t is equal to f of x, so we could replace t with f of x and write q of f of x. And then we also know that f of x is this quantity x squared plus 9. So we could say q of x squared plus 9. Looking back at our symbols, we would have q of some input, and we now see the input is x squared plus 9. And that would equal the square root of that input, x squared plus 9, plus 1. So what we have found is a new function, the composition of q and f. So we could say we have this new function h of x, which equals q of f of x, which equaled q of x squared plus 9. And when we actually take x squared plus 9 and substitute it into the function q, we end up with the square root of x squared plus 9 plus 1. And we could write our notation this way, or we could also see it as h of x equals q circle f of x. But ultimately, it would still equal x, the square root of x squared plus 9 plus 1. We sometimes call f the inner function and q the outer function. It's important to note that the inner function is actually the first function that gets applied to a given input, and then the outer function is applied to the output of the inner function. In another video, we'll practice identifying the inner and outer functions in compositions.